Thank you very much. Actually, what you have to know about the Commission, Kurt said it all, about our policies, and what I will talk is about actually how the future of science and research, how it is changing and how it might affect our excellence, our position in the world, and our policies. But first of all, I would like to very much thank you, the organizers, for inviting us in this distinguished group of scientists and Estonian policymakers in particular. I'm really pleased that we are here and in this fantastic building, which for some reason resembles very much for the Belgian Academy of Science building, which I used to know when I was still on the other side of the wall, which was doing research. So what I will talk about is a little bit looking into the future, and there is a big disclaimer there. We lack evidence of what the future will be, but which is of course a kind of a statement where you can kill every debate. But what I will try to do is to bring forward a few changes in how our science system is changing and how it will affect us. And I will try to do that by using a lot of examples and by bringing forward a few of the key trends which we can already observe today. So, just if you look around what is happening today, and you would try to, or you read the papers or the literature like Nature and Science and so on, you see a lot of things happening on the ground, and they look all disconnected. For example, the stories we give there is one good example of citizen science, which I'm sure you know very well, is Galaxy Zoo, which is a kind of an enormous open way of doing research into classifying galaxies, which involve 150,000 volunteers, which have classified more than 10 million images, etc., etc. Another example which we have there is network science. There is an initiative called Synaptic Leap, which is an open, it's a kind of a Facebook type of doing research on biological, on drug treatments, and it is quite successful up till now. It is not doing research in the classical way, it is doing in a much more open and collaborative way. A third example is the open data, from the open data field. There is much more open data, of course, than the example there, but I'm sure you all know this famous recent issue, and it probably contributes to some of the skepticism science is meeting today, which have been discussed by my predecessors as well, where the famous piece of analysis by two economists which show that when the debt GDP ratio is going above 90%, it slows down dramatically growth, and by consequence a lot of national policies have been based on that to cut expenses. Well, by opening up the data, some of the researchers somewhere in another university found out the mistakes and published the mistakes, and by consequence the whole fundament of a lot of our fiscal policy seems to be a little bit based on a small basis. Another example, and that's where my interest came when I still was on the research side of the spectrum into new ways of doing research in science, is the whole, and I'm sure here in Estonia you're familiar with this, is the whole movement of open source software like Linux. If you study Linux and the way it is produced, it is a lot of science behind it, a lot of research behind it. The way they standardize it, the way they do quality assurance, the way they do peer reviewing, it's all happening in a non-traditional way, in a non-institutional way, and still it functions fantastically well. Linux is as competitive or as performant in the levels of services that it offers as whatever commercial or publicly driven software platform. So all these dots, if you put them together, you see something happening which, for the sake of simplicity, we call Science 2.0. And the key question is, and there is of course where the speculation starts, are we at the beginning of a changing modus operandi in science and research? And if so, it will need for us to rethink our institutional facts of scientific life, the way we do it, the way we make careers, the way we make disciplines, the way we make curricula, the way we use scientific methods. And as a consequence, and that's where my present job comes in, it will have impact on research and innovation strategies. So that's actually the project, and I will come back at the end what the Commission is doing there. We are working on in Brussels, and by a Perez change, maybe you know Perez, because I think she's part of the business school in Tallinn. She's a quite famous economist who described the 6 big changes in techno-economic paradigms of the Western societies of the last 250 years. So it means a fundamental shift, not an ephemerical shift. Anyway, the question is this beginning? Is it only anecdotal, or is it more systematic? And if so, what are the consequences? So this is the structure of what will follow. It's only in 13 slides, don't worry. But let's start with what is going on. What you can see very clearly, and the examples are already an indication, is an observable explosion in availability of data, in knowledge producers active at the global level, and in publication platforms of all kinds. We gave a simplistic figure there, but if you take some of the data points, authorship is growing tenfold each year, where before it was only it grew tenfold every 100 years. Data, I'm sure you know this, every 2 days we create as much information as we did up till 2003. So this explosion is taking place. Now, what kind of sense do we have to make out of that? And where does it come from? And that is an important thing. That's where connecting the dots is more than putting the details or the case studies together, where I think it is a systematic process. If you take the scientific process, and forgive me you all know it certainly much better than me, but you start the analysis, publication, review, conceptualization, data gathering. The way we used to do it was libraries, peer-reviewed journals, etc., etc. So let's cut the story short. You know all that, but what you see happening is that every part of the scientific process is being challenged by a new way of doing what we used to do. You get citizen science in terms of bringing in new power for analysis. You get open code in terms of publishing it. You get preprint type of databases where you can discuss already emerging results. You have open access with regard of the publications. Kurt mentioned it before me. You get the creation of alternative reputation systems for determining how someone who is in the preprint, for example, very popular, is building up a reputation, etc. You create collaborative bibliographies like Mendeley. Scientific blogs are exploding and taking a very important part of how reputations are built. Open annotation systems facilitate the scientific the process of actually going from conceptualization to gathering. Open data again. The Commission is trying to push very much. Open lab books, the example I gave in the beginning, etc., etc. And all this, you get many examples of it. And actually, just not for the fun, but to show you that this is real, that this is happening now, at every dot in our papers, we can come up with a lot of examples. Startup companies, private, not-for-profit, profit, etc., are being very active there. So it is something which is happening now, which is real, which is not an imagination of some futurologist, and where you see slowly emerging a new ecosystem, and that's a very fashionable word, for services and standards with regard to how you do research, how you publish it, how you collect data, how you create reputation, etc. And just to give you one example, you probably all know Mendeley, which is a collaborative type of making the bibliographies. Well, it has been sold a few months ago for 50 million euro. It was created 3 years ago by 2 Germans, or 3 Germans, I think. Sold for 50 million euro a few months ago to Elsevier, which is in itself an interesting thing to remember. But anyway, real things supported by real initiatives, public or private, happening today. So the whole thing of Science 2.0, and that for me is the most essential slide. If I have to tell the story in a certain way, it is much more than open access only. Open access is only one part of the whole cycle, which is being opened up, which is being done in a new way, which is creating new potentialities. So that is what is happening. If you connect all these dots, why do we have an explosion of data authors and publication platforms? Well, here you have, I think, a part of the explanation. It is driven by what you see happening here. What is the impact? Now here, and this is always very difficult to try to say it in a compact way, but in a certain, if you would have to resume it, what you see happening is that it is more than a marginal change. It is really a change in modus operandi, where this is how we did it traditionally. This is, well, how we did it, how we still do it. It's not like it's yesterday. It is something which is going on in parallel, and this is the emerging trend. And there you see the initiatives. There you can clearly see that we get, if this is paradigm one, in how we did research and science, this is the emerging trend. Will it become paradigm two? Question mark. I cannot foresee it. No one, I think, can foresee it with a level of accuracy which is more than guessing. But still, it is a trend going on, and it is important to bear it in mind. So the impact is really a changing modus operandi. I come back to what are the consequences of that change. Secondly, some of the authors which are studying this phenomenon are even translating it at the meta level, where this whole openness of the research and science process will lead to a new way, a fourth paradigm of data-intensive science. So due to data abundance, you will get a much bigger role, not only for inductive science, but not only for hypothesis-driven science. So, to put it with a boutade, here is the evidence, here are the data, now what is the question? It's a boutade, but it illustrates you some of the issues which are taking place. And do not forget, data explosion is only starting. If we have the Internet of Things, if we have smart environments, if everything is connected with a sensor and an actuator, you will have an exponential explosion of data which we can hardly even imagine. So the data abundance is not to be stopped, it will only continue. And hence, some of the authors, and personally I do not feel too competent to discuss all this, but I find it an interesting way of thinking, is that that we get a kind of a first paradigm which is data-intensive science based on, here's the evidence, where is the hypothesis. If that is the case, suppose this is correct, it means a fundamental challenge to our traditional way of teaching research and science. That's the inevitable consequence if it is correct. And there I still think we cannot be too conclusive today. Another observable impact is by opening up the science system, you get a much more productive science and also better science. You also get the dark side of it, but for sure. But we can come back to that later on maybe in the discussion. So much more productive in terms of you get new types of scientific outputs, just like data sets, code, contributions to wiki and so on. And I find it interesting and illustrative that the National Science Foundation in the US, from January onwards of this year, assesses if you submit a research proposal, your CV, not only on the top 5 publications, but on the top 5 products. So they ask you to list top 5 of your products, be it an article, be it a data set, be it an algorithm, doesn't matter. As long as you say for yourself, this is my most important contribution. I think it's an indication of a changing paradigm. You can use the same data sets for multiple research. The traditional example is 50% of the Hubble papers came from reusing the same data. Crowdsourcing is improving a lot the productivity of science. The way patents are evaluated today in the US is a peer-to-patent system, as they call it. They put it actually in the open and via a rather sophisticated system of reputation analysis, thousands of people can contribute to evaluating the patent, and as a consequence it goes faster. Not people in general, scientific people. You get a faster circulation of high-quality ideas, and 70% of the publications discussed in the blogs today, which are very popular scientific blogs, come from high-impact journals, and so on. You get better science, also, which is always, it's better science is like excellent science. How do you define it? But we had that discussion before, so I refer to that. It's probably the same, but just to indicate what I'm trying to hint at, you get greater falsifiability. By opening it up, you can reproduce, you can redo the tests and the experiments. You can check it much easier than before. There is also, of course, and that's what I said, the dark side. There is much more opportunity to tweak the results, but there is also much more control possible. So I think there is a balancing going on there, and it's interesting to see how that will develop. There are websites in the US which are dedicated to only doing that, to find out where the misfits are by using the open data. It's easier to follow the process of the scientific project, so to speak. You do not need to wait for the end product in order to be able to use it or to reject it, which might lead to a much more productive science. Easier to find mistakes, etc. So there are some first observable impacts available there. Is it a system? Again, difficult to predict, but it goes in a certain direction which is quite important. The question is, sorry, is it irreversible what is going on? Can we stop the whole explosion of data, authors, publication patterns? Can we stop, if we would like to do that, can we stop this opening up of the science? I personally think, that's my personal view, well, and shared by other people, but this is not a commissioned position, by the way, so I personally think it is very, very unlikely it is reversible. On the contrary, why? And this has nothing to do with the internal scientific dynamics per se. It has more to do with the environment of science and research today. First of all, we have an explosion of scientific centers institutions in the old centers, if you take Europe, but also the higher education system has since World War II almost doubled in Europe, so there are much more institutions there. There are much more institutions take universities, due to the globalization of science. China will most likely have the biggest research population quite soon. And of course, which means there are much more research, much more PhDs, much more pressure on the system to publish, to have research, to have data, to go out, to make a career, etc. But also of demographics. To keep up with the expected rise in students due to the demographics of the world, that's an article, a calculation from Nature, we would need 4 new 30,000 students, universities per week to create. So if we would follow the demographics, the students that would hit the market due to the university due to the demographics, Nature came up with this figure, which I found a little bit exaggerated, but Kurt, you know what to do in the coming. So if you want to find new leerroos, maybe you should go here as well. So that means we have the largest amount of active scientists. We have it already today. It will only increase, and it implies a huge need for platforms to make a career, to publish, etc. That is something to not to forget. Nature gets, if you take one of our star magazines, Nature journals, sorry. If Nature has 11,000 articles submitted per year, publishes 800. If you put that against the explosion of scientific authors, actors, and people wanting to make a career there, it is quite clear that only Nature cannot cope with that. As a result, you have an explosion of open journals, and it will only increase. They publish. It is much quicker to do, they can publish much more, and it is in a certain sense also cheaper to do so. It is very difficult to see that open science and open publishing, will diminish in the future. That doesn't mean Nature will disappear, it means that the system will get, maybe balanced is the right way, but you will get a counter reaction there. It also explains why massive open online courses are so popular. If this is the pressure of the system, it's quite logical that this is the answer, except if Lero will open up its doors to, 30,000 students per week to add, so it is impossible physically. So you get a kind of attention there which you can only resolve by opening up the system. Second driver, which I think is very important, is that our societies do demand science to come up with quicker solutions for the grand challenges. It's quite clear that there is a pressing need to fight the demographic, the impact of demography, of climate change, and of new energy needs, etc. And there, if the analysis is correct, maybe the opening up of science is one of the ways to get quicker results. So, the diagnosis is that in terms of drivers, the pressure from an increase of input into the system by actors and by problems, looking for an output in terms of publications and careers and solutions, is probably the biggest driver why the system as it is will change and will go into much more openness, the circle I described in the beginning. Secondly, do not forget, and that is something that didn't exist 20, 30 years ago, there are technologies available which make it very cheap to do it. Web-based, because it's all digital driven, of course, it is so cheap to do it that there is no reason to think that there is a technological hurdle there. On the contrary, the costs to bypass the system as it is are quite low. And thirdly, which is something I think we tend to forget, but the Facebook generation will hit our laboratories in 3 to 5 years. So sharing will be the standard. I mean, I was not dedicated in sharing my results. I'm sure most of, well, let's say half of you here, and to be polite, probably we were all very protective for our data because that was the way to do it. We had to work hard, etc. But in order to get our PhD grants, etc. But now these people are different. They really are thinking in another modus operandi already. So they will probably extrapolate it to their scientific world. Just an example, very quickly, but this is the explosion in open online education. This is when it started, and you see that parallel with what I just said, the push for more opportunities to study, the push for more for more ways to get an education, the fact that the traditional system cannot follow, explains you why these MOOCs are suddenly so popular. It is simply because it responds to a certain demand. Now, are the MOOCs, the companies which you see, Coursera, Udacity, Meta, edX, etc., is this the final product of the future? I don't know. But the fact that it will go in that direction is very likely. So in one word, Science 2.0 is probably here to stay. Why? Because it is driven by an explosion of actors and knowledge. It is driven by a demand for faster science. It is driven by a demand for catching up. Not one country in the world will accept that they need to wait 100 years to build up an excellence. It is simply not reasonable to assume it, so it has to go faster, and Science 2 might be a way of doing it. It is pushed by demographics, and it is made possible, low entry barriers, by cheap and easy to use ICT. It's as simple as that in a certain sense. So I think it is irreversible. Now, if it is irreversible, and that's my penultimate slide, then we have some very important policy consequences. First of all, the old ideal which I'm sure most of us got when we were at university, as a scientist, as an academic, you need to be an encyclopedist, you need to know as much as possible. Of course that is gone. In a world of data abundance, this is quite ridiculous. But at the same time, for people like Wittgenstein to take one of the most well-known examples of someone who had it difficult to get his science published, well, he would have it probably much easier today. He would just open a blog and start or write something in some of the networks, and probably his fame would go before his nomination in Oxford or Cambridge. I forgot that one, but anyway, it shows you the two sides of the coins. The scientific powers that be. And the analysis of Paris, the economist of the beginning, is that the institutional powers that be in a paradigm shift will have to change or adapt. Well, it's not very unfeasible to imagine that indeed as the example I gave there with nature, these scientific powers that be, if they don't adapt to the new situation, they will probably disappear, at least, or decline in importance. And I cite nature because I know this is one of the companies, and it's the journal, but the company behind it, which is doing a very intelligent way in trying to embrace these new tendencies. We will get new ways to determine reputation, to make CVs. The example I gave of the National Science Foundation is one example. The Deutsche Forschungsgesellschaft, also this year or at the end of last year, decided that when you submit a proposal, you just give the 5 most important publications, regardless of where they are published, which means the powers that be, so if that gets generalized, that it doesn't matter where I publish, as long as I say these are my 5 most important publications, it means that the high impact journal system will be fundamentally challenged. And the reason why they do it is, of course, because it's the only way to try to find new ideas, because we all know that the peer review system is not exactly the one which always pushes for the fastest new ideas. So it's a vicious circle there. You will get new gatekeepers. You will probably get more Creative Commons as a license system, more open access. This is de facto. This is almost, well, that doesn't need much more explanation. You will get more citizens-based science, but I personally think that it will not be the people in the street type of citizen. Of course, it means the lay scientist which at home wants to contribute in experiments or whatsoever. Faster science, data visualization will become a key kind of technical language, and statistic a key science for the future. Given the only way you can handle data abundance is by knowing statistics and by visualizing it in a smart way. Otherwise, it simply is impossible, in my view. Knowledge management will probably be a skill, a vital part of future academic education. This is, I find, very interesting, because we have more abundance. Give me the data, here are the data, where is the evidence? It will also help us and free more time to think really the questions through. So learning to think again, learning to formulate hypotheses is probably something we might consider putting in our curricula in 7 or 8 years. New curricula are probably needed to capture what is going on, and new metrics in terms of importance, reputation, impact, etc. are certainly needed. And there are some interesting projects going on in the US on using Google type of algorithms to determine your importance in a social network environment of scientific communication. So all these are the things which are there and which deserve, I think, our attention. Now, this is, I come back to the slide before, but this is what we will do with the European Commission. So we will make this an important part of our future policy development. So we are launching what is called the green paper process, meaning a European discussion on the validity of the trends, the validity of the analysis, and the potential implications it has for us to take or not to take. Do we need policy here or don't we need policy here? I don't think we should have a predetermined mindset there. It can be just let it happen, or it can be, well, maybe we shouldn't. Maybe we should try to stimulate it or not. It depends. So it's an open process, which I'm sure you will get, some of you are invited to participate already, but then it goes into the whole European debate. So the academies, the research centers of excellence, LERO for sure, all these actors, important actors, we ask them to contribute. Now, just to wind up, because what I presented is a little bit, every time I do it, I see the skepticism, and I'm also skeptical myself. But then, to overcome your skepticism, just for the fun of doing the exercise, in 7, 8 or 10 years, we have to create a new center of excellence here in Estonia on subject X. And you're looking for an excellent team to start to build it up, meaning, as was discussed before me, yeah, you need excellent teachers and you need excellent researchers. Now, you get your CV, you do a publication, you get the CVs in, and you have to choose, you have to make a decision between the following. First of all, you get an excellent, let's say a candidate X which has a good education in maybe some of the Lero universities, let's make it easy, and a competing candidate is someone who would follow on top of that, not a master somewhere at another university in Europe, but has made his master based on massive open online courses, taking the best from Stanford, Harvard, and maybe Shanghai, because don't forget, these people are performing very well. Who would you choose? Second example, between those two candidates. Second example, and that is, I think, more tricky, but it shows you what more profound what is going on. You have to create your research team for the laboratory, and you can choose between someone who had an article in Nature, to quote Nature again, or someone who maybe has not so many articles, maybe one or two in some obscure journals, but is the author of a scientific blog on that particular subject, which is read by the key community, the scientific community of that subject. And you can measure that. It's very easy to measure what kind of ideas are taking over in this. So who would you take there? The person with the Nature publication, or the person who is actually perceived by his peers to be on top of the field because they read all his blog and they use it? Now, if we are honest, I don't think it's very simple to say, we go for the traditional approach. We go for the person with the traditional degrees, and we go for the Nature person. I think if we are really honest, we will be tempted to also look very carefully at the second person. And that is probably what will happen. Now, if that materializes and becomes systematic, it really means that we have a Science 2.0 paradigm shift. Thank you.